In this lesson video, we are going to look at oxidation numbers. Let us start. Oxidation numbers, it has to do with the charges of the compounds or elements. Normally we use, as you all know, that we use molecular formulas to describe a certain compound, and then on top, this position is where we see the oxidation number of that compound or element. In this case, the oxidation number of OH is 1 minus. Normally, in mathematics, we say it's -1, but in chemistry, it's 1 minus. Then the oxidation number of hydronium is 1 plus. If you don't see any plus or minus here, know that the oxidation number of that particular compound is 0. So in this lesson video, we are going to determine the oxidation numbers of each element in a compound. Like for instance, sulfuric acid, we want to know the oxidation number of hydrogen. This lesson video is based on that. We are going to calculate oxidation numbers of each element when we are given the molecular formula of a compound. Before we get to the core of this lesson video, there are a few things that we should take note of. Now, what you need to know is that all the elements in group number 1, I'm referring to metals. The oxidation number of each element is 1 plus. Group number 2 metals is 2 plus. And then oxygen usually has oxidation number of 2 minus, except in peroxides and difluoride oxygen. Hydrogen is 1 plus except in metal hydrides. Fluorine is always 1 minus. Chlorine usually is 1 minus except compounds with oxygen and fluorine. You should take note of this. It will assist us a lot when it comes to determining oxidation numbers when we are given the compounds. Our first example is magnesium oxide. What is the oxidation number of magnesium in this compound? We should take note that this is not a peroxide, so the oxidation number of oxygen is 2 minus, and then you can see the overall oxidation number of this compound is 0. So we have magnesium plus, actually let us use variable x, we have 1 atom of magnesium, so it will be 1x plus 1 atom of oxygen, it's 1. Then the oxidation number of a single atom of oxygen is -2. It's equals to the overall oxidation number, which is 0. Then from here we have x, positive 1 multiplied by -2, it's -2, it's equals to 0, x is equals to 2. So we conclude that the oxidation number of magnesium is 2 plus. And magnesium is a metal in a group number 2, so that is why the oxidation number is 2 plus. Our second example is oxidation number of oxygen in this case. As you can see, this is not a metal hydride, so it simply means that the oxidation number of hydrogen in this case is 1 plus. So we have 2 atoms of oxygen, 2 atoms of hydrogen. Then it's 1 plus x, it's equals to the overall it's 0. 2 multiplied by 1 is 2 plus x, it's equals to 0. X is equals to 2 minus. Let me actually write it like this. Then we conclude to say oxygen is 2 minus. What is the oxidation number of nitrogen in ammonia? So we have x plus 3, 1, it's equals to 0. X plus 3, it's equals to 0. -3. 3 minus. Nitrous. What is the oxidation number of nitrogen? It's X plus 2 negative 2 is equals to 0. X is actually 4 equals to 0. X equals to, so nitrogen in this compound is 4 plus. You can see that it depends which compound nitrogen is in. For ammonia it's 3 minus, but for nitrous it's 4 plus. For the following examples, try to work them out. The oxidation number of hydrogen in this compound, I'm looking for hydrogen. Also hydrogen. And then for this one it's oxygen. So for this one it's hydrogen, for this one hydrogen, this one hydrogen, and then for this one calculate the oxidation number of oxygen. Pause the video, work out these questions, play the video to verify your answers. So for the first one, this is a metal hydride. So it simply means that the oxidation number of hydrogen in this case is 1 minus. Remember the basic knowledge behind this. The oxidation number of this plus the oxidation number of this must give you the overall oxidation number, which is 0. So in this case, hydrogen needs to be negative. And then lithium, we know that it's a metal from group number 1, it's positive. So positive 1 minus negative 1, it should give us this number. So hydrogen cannot be positive because 1 plus 1, it will be 2 instead of 0. Same goes to this one. Sodium, it's a metal from group number 1. So hydrogen automatically, actually hydrogen needs to be 1 minus in order for the oxidation number to be 0. I mean the overall oxidation number. This is a peroxide, so the oxidation number of oxygen in this case must be 1 minus. Because if you can calculate, we see that the overall is 0. We have 2 atoms of hydrogen, 1, plus 2 atoms of oxygen. And then it's 2 plus 2x, it's equals to 0. We have 2x, it's equals to negative 2. We divide by 2 both sides. This will result into 1 multiplied by x, we have this, and then it will be negative 1. What is the oxidation number of oxygen in this compound? We can see that the overall is 0. So we have 2 atoms of fluorine. Fluorine is always negative 1. Plus x is equals to 0. We have negative 2 actually. Plus x is equals to 0. Then x is equals to positive 2. You can see that the oxidation number of oxygen varies. It depends on the compound. What is the oxidation number of nitrogen in this ionic compound? Now you can see that the overall is 1 plus, and then we have 1 atom of nitrogen plus 4 atoms of hydrogen, then we have 1, it's equals to 1. x plus 4 is equals to 1. X is equals to 1 minus 4. X is equals to negative 3. What is the oxidation number of phosphorus in this ionic compound? Now we have X plus 6 atoms of fluorine. Fluorine is always negative 1. It doesn't matter whether it's ionic or it's just a compound. And then the overall net oxidation number is negative 3. Negative 6 is equals to negative 3. Negative 3 plus 6, we have 3. What is the oxidation number of sulfur in this compound? We have X plus 4, negative 1 is equals to 0. Negative 4 is equals to 0. X is equals to, oh no, X is equals to 4, positive 4. That's it for this lesson video. This is Wahula SJ. Thank you very much.